Okay, Patrick Gilmore, are you out there somewhere? Okay. All right, we're going to go ahead and get started. First up, we're going to start with Fredy Kuenzler from Init 7.
So good afternoon, everybody. Thank you for having the opportunity to talk here. This presentation I'm going to give is actually an updated version from RIPE in November last year. It was in Prague, I believe. No, it was in Prague. It was in Budapest, somewhere Eastern Europe. Anyway. It's going to be about Pillory, and so that's me. You have all the contact information. The agenda, a few words about Init 7, actually no words about Init 7. A few words about eyeball traffic engineering, and then the problem, what we face here is the more specifics. Init 7, I'm going to skip this. As you're not supposed to watch marketing slides, disclaimer, and I'm on slide 7 already, which is good for 1 minute talk. So it's about peering. We love peering, don't we? We try usually to peer away as much traffic as we can, as it's reducing our transit costs. And tier 2 networks, they usually are connected to multiple internet exchanges and have a number of private peerings, and this is not new for you. 60–70% probably is of the traffic is peered away, and they also see half of the routing table via peering BGP sessions. If we look from a content perspective, we try to peer away as much as possible, as close as possible. If we look from an eyeball perspective, inbound-heavy networks, they try to get the traffic as close as possible, usually, and sometimes they fight against expensive saturated links. So these measures they take for load balancing traffic is sometimes a bit difficult, and if we compare these two networks, content versus eyeballs, the interests of these two network types, they are contradicting. So what do the eyeball networks to engineer their traffic? Usually they are short on money. The need of capacity is growing, and some links get saturated and some are less saturated. What they could do is actually described in my slides. I gave on several locations. I presented on several locations. So you have the link there. You may want to look on that later. Just a short summary on these slides. Prepending, this is what networks usually do. They also do selective announcements to various suppliers, and with the drawback, of course, of less redundancy. They also could do community-based traffic engineering. They instruct their transits to prepend or not to announce to certain networks prefixes. This is tentatively the best way, and there is also a very small link on this slide you can click of a collection of community support papers of various vendors. What they also do is they announce more specifics. And here starts the problem we face. A number of more specifics are actually okay or acceptable if they're used smartly and decently. But what we also face is massive deaggregation. And as a matter of fact, here is the number of 40% rubbish in the global BGP table is inaccurate. It's actually more than 50% these days. So this is what we face, what we see every day, and it's getting worse every day. Most of you likely know the CIDR report. It shows how much smaller the global BGP table could be if everybody would aggregate neatly. So this is almost the latest screenshot from February 4th. It's 42.2% we would gain if everybody would aggregate. And when I updated the slides, I updated it from RIPE from November, and it went up almost 1% within the last 3 months. So what happens to the polluters? In the Middle Age, they were put into this pillory. So, any volunteers? Pollution of the global BGP table is really an issue because we see, if everybody would aggregate, we would see less memory usage and faster BGP conversion, less CPU cycles, and last but not least, a longer life of your equipment. I just read an email recently, an advisory from, I don't know, some internet exchange, I think it was NLIX, saying that the Brocade or former Foundry RX series cannot handle more than 400,000 routes, and that's where we're going to be in about 2 weeks. So why are networks selfish and don't aggregate neatly? Well, what we could put in these slides now is a list of the biggest polluters, but this is not what you want to see. You're probably more interested in how can you avoid it. Well, other than traffic engineering, the deaggregation reasons we see is, for instance, no export communities, simply not set. People forget that. Or people forget to configure neighbor, whatever, send community. They have no clue. This happens, yes. And what I also think happens is that some people which sell consulting actually promote the aggregation. So what I suggest is please evangelize aggregation, aggregate yourselves, aggregate your customers, talk to them, please aggregate if you can, because there is no reason to deaggregate the /19, for example, into 32/24s, but this is what we see. All right. It damages the content networks. Why? It's a reality, and it won't vanish, so we have to figure out a way how we can avoid it. Deaggregation makes us learning more specifics from transit, because people tend to advertise various smaller prefixes or more specifics to various networks, to various transit suppliers. And they actually are often covered by less specific prefixes from peerings. So the traffic engineering effort of content networks is pretty much useless, because whatever we configure in BGP regarding regardless of local pref or MEDs, it's overwritten by the more specific, and the result is traffic is actually shifted towards the expensive transit link, while it could be handled easily via a cheaper peering link. How can we avoid the damage? If your network is outbound heavy. So we did some analysis of the routing table, and these are bad examples, how it actually looks. I anonymized them as I'm not supposed to put anyone into pillory. So we see here, can you read it? I think /15 network is actually deaggregated in a number of /18s, and those are even more deaggregated into /19s. And there are about 3 dozens of these prefixes just coming out of one /15 network. Or we have another bad example. /13 network is massively deaggregated. And of course, this is only just an example of the whole show. What can we do about this? As there are too many more specific prefixes advertised by transit, manual filtering is not an option. We're talking about several tens of thousands prefixes we could filter away. So we cannot handle this manually. And once a prefix filter is applied on the transit link, the more specific prefix has vanished and is no longer visible in our BGP table. So this makes also automatic checking for black holes difficult. What we also don't know is how the routers behave when we apply a prefix list with several thousand entries. We did some tests for a number of prefixes on Brockhead XMR gear. It resulted in a very time-consuming BGP conversion. So more than 10 minutes for a list of, let's say, 100 or 200 entries. And the risk of black holing is severe. Some networks do a lot of deaggregation, but they don't announce a covering prefix. So we have to leave them on in the table. Or they change their policy and it goes away and all of a sudden we have a black hole. So we did some further research. We scripted an automated filtering system based on the Piranha BGP daemon and route collector. And we originally thought we're going to publish this in a GPL-alike license for others. But the plan changed. We're not going to do that. And I'm coming to in a minute why we're not going to do that. As mentioned, for this script, for the processing of the prefix list, we need an unfiltered dump of the BGP feed. So when you have a feed, a transit feed from a supplier, as soon as you apply filters, the more specifics go away, but then you cannot process them anymore in a script. And so we had to first figure out how we can process the filtered prefixes. We actually go with the CLI shell with a show IPBGP neighbor received routes command to actually get the dump of the prefixes we get from the supplier. We dump then this to the Piranha BGP daemon, and it's not the foreseen way of feeding a Piranha, because a Piranha is actually just a route collector with a normal BGP session. But it eliminates the need of asking the transit supplier for a separate feed, which actually would be configured with an eBGP multi-hop to our route collector. So we did that. We figured that we actually could save quite some traffic, and this is a graph from our S-flow data to one of the major tier ones. And we had, when we applied this filter list, it dumped for about even more than one gig traffic to just one of the so-called tier one carriers. So we thought this is promising. We started to refine the script, and the prefix list became huge. So it was actually, I think, more than a couple of thousand lines. And we applied it to the router, and it worked. But after doing this, we couldn't save the configuration anymore on the router, because obviously the memory is too small, and convergence took hours, not just minutes, it took hours. So the consequence is, this is not a viable way to go. We cannot just apply prefix filters and hope that everything would be fine. And that's why we decided not to publish the script we made. It's actually very alpha, and we have to think of another solution. So how can we do that? Without overloading memory, router configuration, CPU cycles. And probably the smartest way would be a new feature which is not existing. But if we can have a feature which says basically neighbor whatever suppress more specific on just one neighbor and not on a global basis, it would allow us to filter more specific from one feed and to keep them from another feed, which would be pretty neat. And so not sure whether this is ever going to happen, but if the community supports it on a large scale, probably the vendor would listen to us. How would the feature behave? Actually, it should be, it's supposed to be enabled or disabled per neighbor, and of course not enabled by default. It should just dump any received routes from the RIB fib if covered by a less specific route learned by the same or another neighbor. And it must be dynamic. Whenever a covering prefix vanishes, the previously dumped prefix must become active again. We thought of other options as well. I talked to a number of people of this community, and the one proposal was we could have beside the router some Quagga or OpenBGP box with actually would inject a modified BGP feed with rewritten next hops. This could be an option. The advantage is if the box crashes, there is no outage because the BGP just would work the normal way. The disadvantage, we never tested it. We have no idea whether it's going to work, and it's likely quite an effort to get this program done. And another option would probably be a large-scale prefix filtering along the RIR boundaries. There is a very old presentation from a colleague of the Swiss community. Some of you may know that Swisscom is actually doing this on a large scale, and the description is in this link, how you could filter along the RIR boundaries. The BGP table reduces significantly, so you save memory and CPU cycles. The disadvantage, it requires default routes or pseudo default routes. Otherwise, black holing is a fact. And on top, it's probably not going to work very long because more and more IRRs are going to give out more and more /24s, so this filter solution is not going to work. So, and this concludes my presentation. We have a couple of minutes to take questions, and I'm happy to discuss this also offline or after the presentation in the breaks. I really wonder, what would you do? Would you support a new feature which would suppress more specifics? Yes, please.
Randy Bush, IJ. Thanks for this, President Fredy. It's a constant help. A set of three-step knobs like this have been filed with Cisco and Juniper for over 5 years. There are problems with them, and you have to go down in the details. For instance, in your next slide, you will see where you say dumps by less specific learned from the same or another neighbor. If you dumped it and then the neighbor withdraws the next specific, you lost it.
Yeah.
So there are details that have to be worked out, but these have been filed with the vendors for well over 5 years. The hidden problem is just in the cost you're talking about when you try to do it with route filters. Effectively, those same costs are going to be paid in a different way. You're not going to have the problem loading the configuration, but you are putting a compute load, right? But it's in the try, so you know it's down there, you know. So it's not so bad, but it's still a load and a little complex.
Yeah, but probably these engineers, they are smarter than we are. We operators are to handle this issue. But thanks. Yeah, it's good to hear that we have this filed already with the vendors for 5 years. So we just bring the topic up again, and it's like in politics. You have to talk a bit again and again until you reach your goal. Yeah, please.
Jeff Haas, Juniper Networks. Randy has some very good points in that once the prefix has gone away, there's no useful way to get it back. Even if we had something like a one-time ORF that says, get me back the more specifics, that becomes very expensive to run. You end up effectively refreshing your box to death if you're going to do something like that. You can't blame that one on me. There's also, I don't know if slides actually covered it because I came in the room slightly late, but one of the problems with doing this type of suppression is that it's very important to make sure that the AS paths are pretty much identical when you're doing the suppression. Because one of the things that we're going to be running into over the years as address space is being exhausted, people are going to be taking their /16, for example, continuing to announce that for their reachability, and then basically subletting access to individual /24s. That doesn't mean that there's any guarantee of there being global connectivity from that /16 network to sublet space.
Yep.
So doing that additional check of making sure that the paths are congruent with each other, even if we decided that the refresh problem was solved, would also have to be taken care of.
Yeah, good point. Thank you.
Yes, we're pretty darn close.
Could you walk up to the mic, please?
No.
Oh. Okay. Anyone else?
So can you show a hand, would you use such a feature if it would be available, please? Oh, at least a few. Thank you. Thank you.
Thanks, Fredy. Okay, next up we have David Applegate from AT&T Labs.